Okay, so in forces, the basic thing we have the first law of motion. What is the first law of motion? Can you describe?
The object remains stationary or moves at a constant speed unless an external force is applied.
Yeah. So what are the two states you can say in which object continues its state of rest or uniform motion? See, one is the rest position. What is the second other position?
When the forward and the backward force is equal to each other.
Yeah, so you can say constant speed also. It is only possible when the forward and backward forces are equal. So the object will start moving in the constant motion, speed or a constant motion. Yeah. So here you can say either rest position or the constant motion. Okay, so the next thing in the first law of motion, we have, you can say that the submission of forces. The submission of forces, it can be in it can be in y direction, it can be in the x-axis direction. So in both cases, they should be balanced. So submission of forces in the x direction, it should also be zero, and the submission of forces in y direction, it should also be zero. So you can say in x direction, forward forces should be equal to backward forces, and in y direction, upward forces should be equal to downward forces. So you can say it is also the condition of equilibrium. Okay, so the next thing is the law of inertia. What is the law of inertia? Do you know it?
The property of an object to resist a change in motion unless an external force is.
Yeah, right. Property of matter to resist sudden changes in state of rest or motion. Okay, so the next thing is we have so these are all the forces are acting on the object. You can say the object is this in the middle. This is, you can say it is force G. This is force F. This is force also F, and the downward force you can say is weight, which is 100 Newton. So in this case, this all are the forces that are acting on the object, which is here. in the middle. So now, as I said, that the object is in state of equilibrium. So all the forces should be balanced. In this case, we don't have the forces, so we have to draw the forces so that we can balance all the forces. So in this case, we have already studied in the kinematics chapter, every inclined force, you can say, or direction, you can say, have the vertical and the horizontal component. So this force would have the component like this and like this. It would be F sine. I am taking this angle as 60. So it would be F sine 60. It would be F cos 60. Now same goes for the downward force, which is this one, F, and this. Here I am taking angle as 30. So it would be F cos 30, and it would be F sine 30. This is all the forces we can resolve. We say this thing resolving. When we distribute the component of inclined thing, this is the inclined force, you can say. So we always distribute it in components, the vertical and the horizontal component. So and we say this all the thing resolving. So I've just resolved all the forces. Now I can write it as, in the x direction, summation of fx should be equal to 0, because I said the object is in equilibrium. So the forces acting on the x direction is g, which should be equal to f cos 60 plus f sine 30, right?
Yes, sir.
And tell me about y direction. Summation of fi should be equal to 0. So what should I write here? See, in y direction, I can say, yeah, tell me.
F sine 60
Yeah,
equals to 100 plus F sine 30.
yeah,
Okay.
yeah, that's enough to say. So we can say the body is in equilibrium if these two both cases are true. Okay, next thing. The next thing we have is called I just discussed inclined plane. So let's see what are all the forces acting on the inclined plane. Let's draw it the inclined. This is an object traveling on the inclined plane. So first see what are the forces acting on this object. So first there would be a normal contact force. There would be normal contact force. Why? Because whenever object is in contact with any surface, it will always produce a normal contact force. And what will be the direction of normal contact force? It would be in the perpendicular direction to the surface, where it would be to the perpendicular direction. सही है? Okay. So when we it would be like this. Why? Because since we have the plane inclined, so we can say that the force would also be like this, a bit inclined. It would make a 90-degree angle, and we will name it normal contact force. Okay, the next force would be acting. It would be obviously weight, and weight is always toward the center of the earth, so it would always remain like this. It is, you can say, weight. Now, obviously, this weight can also have the three component. You can say one would be like this, because see the object weight I have drawn it is like vertical direction to the object and the center of the gravity. It is always acting towards center of the earth. So I've just made weight here, but the forces should be balancing like this. Wait, let me draw it like this and like this. So now we can say it would be the angle theta here. So it would be W cos theta and it would be W sine theta. So now we can say the normal contact force is being balanced by W cos theta. Yes or no?
Yes.
So can I write here normal contact force is equals to W cos theta here and W sine theta. Okay, W sine theta is weight sine theta. This force is being balanced by either, see the if the object is coming downward, so you can say that the driving force is equal to it. If the object is going above, then you can keep it pushing force. So it depends. Whatever the force is upwards acting like down here or here, it would be balanced by W sine theta. Okay.
So what about friction?
Yeah, that's what I'm saying. When the object is, if the object is moving, then you would be having two forces. One would be in like in this direction, and other would be in this direction. So one would be the friction, and one would be the driving force. So they both would be balanced by a W sine theta. So you can say if it is the driving force, the friction would be here. So you can say the plus W sine theta plus driving is equals to friction. So it depends on the object where it is moving, right side or left side. Okay.
Okay, sir.
So or it would be moving if I change like it is a driving force and it is now the friction force. So for this, I can write W sine theta plus friction is equals to driving force. So it depends on the object. Is it clear?
Yes, sir.
So this is the question. Read this question.
The block placed on the surface is about to slide down the plane. Its weight is 100 Newton. If the max friction force between the blocks and the surface is 60 Newton, determine angle of inclination beyond which the block slides down and the normal contact force on the block at this angle.
Since this is the question of inclined plane, it is already an angle of inclination. So for that, we have to first make a diagram. So let's draw it. It is the object. Okay, the friction force is already given to us. It's moving towards the left. It is in the question diagram and 60 Newton. And the other thing we have given us is weight, which is like this, 1,100 Newton. That's it. Okay, so what we have to calculate the angle of inclination. So what does mean angle of inclination? This angle. Yes or no?
Yes, sir.
Because this is the angle from which box is inclined to the surface. Surface is this the surface, the ground surface. So we have to find this angle. And let us do some other forces acting on the object is the normal contact force. You can say normal contact force, and the other forces is this and this. You can say it, and it is W cos theta, and this force is W sine theta, and theta what of this triangle. Is it clear till now?
Yes, sir.
So now tell me how will we calculate the angle of inclination?
So it will be 100 sine theta,
Yeah,
which will be equals to 60.
yeah, right. So let me write it for part A, 100 sine theta is equals to 60. So sine theta we would be having is 60 over 100. Then take inverse. Tell me what is the angle coming?
36.9.
That's 6.9. So see, we can say that this angle and this angle is same. So we have calculated this angle, and I said that it is also same. So we can say that this angle of inclination is also 36.9. Is that clear?
Yes, sir.
So now whenever the either this angle is given to you or this angle is given to you, both are same, so you can use both since they are same. Now read part B.
The normal contact force on the block at this angle.
Yeah,
So
so yeah, tell.
it will be N equals to 100 cos theta.
Yeah, 100 cos 36.9 since we have the angle. So your answer would be 18. The second law of motion we have Newton. Okay, so this is our second law of motion. In O levels, we had slight a different wording, but in A levels, we have to use this because it also relate to the momentum chapter, which we will study later. Can you read this law?
Newton's second law of motion, the rate of change of momentum is directly proportional to the resultant force.
Yeah. So the formula we have already studied, F is equals to ma, where this F is called the net force or the resultant force, and m is mass and a is acceleration. So you can also say forward minus backward force is equals to ma. Yes or no?
Cancel.
Forward force minus backward force equals to L. Because since we this F is our resultant force. Okay, so a car is traveling. It is the driving force we have. It is the resistive force we have. And the data we have given is the car has mass equal to 750 kg, has driving force 2 kilonewton, and forward horizontal acceleration is 2 meter per second. Calculate the resistive force. Tell me the answer of resistive force. Quick. We have already given driving force, everything. Just we have to calculate the resistive force. What is the resistive force coming?
So I'm doing so.
Sorry?
I'm doing calculating.
Okay, okay.
So 500.
500 newtons. Okay, right.
Yeah.
So now the At what time is your second class? The another class after it.
Sir, 6 o'clock.
So can I teach
Malaysia.
till 2:30 or 2:45 to 3 p.m. Right?
Can, sir.
Okay, so read the question and first draw a diagram, the inclined plane diagram. The way I was drawing the all of the forces. So read the question and draw the just draw the only diagram of it. Okay.
Okay, sir.
Have you drawn it?
Yes, sir.
Then now just compare to the mind and just tell me is it correct or not. The friction force is equals to 30. Since the angle is 30 given to us, so we can say 100 sine 30 and 100 cos 30. Yeah, this is the diagram. That's it. Nothing else. So compare and tell me, did you make the same diagram?
Yes, sir, but I forgot to write the force, the constant friction of 30 Newton at the top there.
Okay. It is given to the part B. Okay. So for part A, it is didn't determine the acceleration of the box if the plane is smooth. Since the plane is smooth, so obviously there would be no friction force. So for part A, we can ignore the friction force and then just solve the equation. You have to find the acceleration. The formula, there's only one formula, which is F equals to ma, and F is a net force. Since
Yes, sir.
we can guess the object is coming downward, so tell me, uh, object is coming down like this. So that this is the only force acting on it, nothing else, since there is no friction. So we can say it is that force responsible for coming the object downward is W sine theta. Yes or no?
Yes.
Yes. So I will write here 100 sine 30. And since we have no friction force because of a smooth path, we will ignore it. The mass given to us is 100 over, you can say, into acceleration A. Tell me the answer of A.
4.905.
Sorry,
4.91, sir.
4.91. Okay. Now for the second part, part B, the plane has constant friction of 30 Newton. So the only additional step would be to minus this force. So we can write this 100 sine 30, since we know that the force which is opposing it's only the friction force of 30 is equals to ma. Now calculate the A and tell me what is the answer.
1.96.
So see, since this is just a box, not a car, so it won't be having any engine force or driving force. So the force which is letting this box come downwards is the only W sine theta. So the direction of the force was like this. So that's why we took this force. If the object, you can say it would be the car or something else, then we might add the driving force or something else. Okay.
Okay, sir.
So you can say this is a frictionless pulley. A frictionless pulley. So you know what is pulley?
Yes, sir.
So it is some type of, you can say, an object from which we can weight also. In traditional times, we use this to weight is pulley. So it has two different, you can say, string, you can say, or even uh, for now, let's stick to rope. So the pulley has connected the two ropes on each side. I can say it is string here, and there is two objects stick to this string. Here is one object, and this is the different object. So I can say this is object B, and this is object A. The mass of this object could be mb, and the mass of this object would be ma. And since the both object is applying forces, which is weight, that's it, no other force, no other force, just weight. So the weight of this object would be like here, this, and the weight of this object would be like this. Downwards, downwards, W, P, W, A. Since if we say that both of the masses have same mass, both balls have same mass, so there would be no movement in the pulley. The pulley would remain like this. But if I say the mass of ball B is greater than mass of ball A, so for that we would be having now a net force. So F equals to ma. I can say W of B minus W of A is equals to ma. So in this case, what will happen? This string will move upwards, and this string will come downwards, right?
Yes.
Yes. So this is what happened in pulley. So obviously the mass is not same, otherwise it will remain same. The mass can also be different. In this case, we will have a net force. For that, what will happen? If in this case the weight of B is greater, so it will move downwards like this, and the resolution of the forces would be like this. Okay, so the mass, it will not remain only m. We will be saying it would be the addition of both balls. So ma